I'm going to demonstrate a security feature of VxWorks called binary authentication. Binary authentication ensures that only legitimate software can run on your device. When you apply power to your hardware, the hardware system finds the instructions for the bootloader and executes them. If you're running VxWorks, the bootloader loads the VxWorks kernel and executes it. The VxWorks kernel, in turn, loads some kernel modules that run in kernel space, and it may also load some user applications and execute them. The problem happens if somebody tampers with your loading process. While trying to load your user application, someone sneaks in and puts in their own malicious application for you to load. Maybe while loading your kernel module, someone goes into the module and changes a critical value in the initialization code, and the VxWorks kernel unwittingly loads a bad kernel module. Even worse, maybe someone has slipped in a totally different VxWorks kernel that can destroy your system. You want the ability to detect and reject unwanted software modules, and to detect and accept legitimate software modules. VxWorks binary authentication gives you that capability. Binary authentication starts with the generation of an encryption and decryption key pair. These keys are generated by the equipment manufacturer. Once a legitimate software module is developed and ready to deploy, the encryption key is used to encrypt the hash of the binary into a signature and placed into a certificate. This encryption key is held as a secret to the company and locked away safely when not in use. The security of the system depends very much on the level of security for the access of this encryption key. Only someone with access to the encryption key has the ability to generate a valid certificate. The certificate identifying the software module as legitimate accompanies the software module during deployment. The certificate stores an encrypted signature that must match its accompanying binary. Note that if someone were to sneak in and change a few bits in the software module or change out the bits completely, then the software module no longer matches what's on their certificate. The decryption key is stored in the VxWorks kernel. When a software module is loaded, the decryption key is used to decrypt the signature on the certificate and ensure that the decrypted signature matches the hash of the software module. When someone tampers with your software module, the VxWorks loader can detect that there's a mismatch between the software module and the signature on their certificate. The VxWorks loader rejects the software module. The same authentication process happens when the bootloader loads a VxWorks kernel image, or when the VxWorks kernel loads user applications, or even when the AMP VxWorks kernel image loads other AMP VxWorks kernel images onto other processor cores. Here is VxWorks binary authentication in action. I'm going to demonstrate the authentication process for the VxWorks downloadable kernel modules. I've created an encryption-decryption key pair. The decryption key is compiled into my VxWorks kernel image, and this image is already loaded onto my target. I happen to be using a Freescale P4080 DS board, which is a Power architecture board. The binary authentication feature is available on all VxWorks supported architectures. This is the serial console for my P4080 VxWorks target. Here is Wind River Workbench, the development environment for VxWorks. I've created a downloadable kernel module. This is a Hello World module called DKM Hello. It contains a function called Hello. I'm going to modify it a bit and recompile so you can see. I'm going to write, I have no signature here, and build it. And so there's my project, it's built. I'm not going to do anything else with it. I'm not going to sign it. So now let's load it. When I go into VxWorks to load the module, the VxWorks loader rejects the module because it is not signed. It says signature validation failed. I cannot invoke hello because that module was just never loaded. Now let's sign the kernel module. I'm going to modify the function a bit. I'm going to say I am signed and build it. Using some tools provided that have access to my very secret encryption key, I create a signature for my binary and incorporate it into my binary. So now I have a module called dkmhello out.signed. I'll load that into my VxWorks kernel image. And it loads successfully. Can I execute the hello function? Yes, I can execute that. Now let's see what happens if I modify the binary. Instead of saying hello, I'm going to take that signed application and I'm going to go into the binary and I'm going to change the bits that say hello into something else. So I'll use a stream editor sed to do that. There's my sed function. I'm going to change hello, take everything that says hello, and I'm going to change it into roar. And the output of that is going to be a binary file called dkmhello outsigned modified. And there's my modified binary. It has a signature and a certificate on it, but I've tampered with it. Now let's try to load the binary. The loading process failed. It says signature validation failed. If I execute hello, I still have my original signed image. This demonstration works the same way at all levels of software module loading. Thank you for viewing the VxWorks binary authentication demonstration.